Hi everyone. So I'm Pierre Deville. So I'm a professor of artificial intelligence from the University of Brussels, and I am as well the head of analytics for Bisnode Group Analytics, so the group level analytics department of Bisnode, which is one of the leading companies when it comes to data analytics within Europe. So as a professor, I've always been amazed by the evolution of AI over the last few decades. And in this presentation, I would like to, let's say, to tell you a bit more about this evolution and how we can leverage it or translate it to one, let's say, one crucial problem when it comes to B2B organizations. And this problem, of course, is how to generate new leads, interesting prospects, so B2B lead generation. So first of all, what is artificial intelligence? So I guess most of you already know this, but AI is not really new, right? So it has existed for more than 6 decades. And when we look at the original definition that people had of AI, well, it's basically the study of machines that can solve a problem which usually requires human intelligence. And over the last decade, of course, there are numerous initial examples where AI systems provided interesting solutions. So some initial problems a few decades ago are, for example, how to beat a kid at the tic-tac-toe board game, or how to design an automaton that can perform a very simple human task, such as playing music, or finally, how to design a simple algorithm that can classify documents automatically. But over the last few years, if not the last decade, we have, however, witnessed a fundamental change which strongly impacted AI development, so AI research. And this change is, of course, well, data. So thanks to our computational capabilities, we can now collect, process, and analyze data like never before. So you already know this, of course. But this impact of data availability has been so strong on the, let's say, on the AI field that if we go back to the initial definition that people had of AI, well, somehow we would have to adapt it, to modify it so that it better reflects the current developments that are being made in AI. So it's still the study of machines that can solve a problem which usually requires human intelligence. But today, these systems tend to do so by perceiving what we call contextual information. Or another way to see this is by collecting and analyzing very large amounts of data that are associated to a very specific subject or a very, very specific topic in order to tackle that specific challenge, right? And again, there are numerous examples over the last few years that illustrate this transition. So today we have AI systems that can beat some of the best players at the Go board game, which is one of the most complex board game ever designed by humans. And these systems do so by, well, first collecting and analyzing billions of data points about movements and previously played games, but also by generating millions, if not billions, of new data points as well in order to take the best decision. Another example is, of course, well, Tesla. Today we have systems that can take split-second decisions by gathering and analyzing data from gigabytes of data from the surrounding. And finally, we also have systems that offer live speech recognition or live translation, again by mastering the language and analyzing millions, if not billions, of unstructured data. So more specifically, textual documents using deep learning or natural language processing. So if we witness, let's say, AI breakthroughs, or at least significant improvements in many different areas, in many different industries, well, there are still some challenges that would still need to benefit from this transition, from this evolution, right? And this is especially the case for one crucial problem for many B2B organizations, actually one of the main problems that they are facing. And this problem is, of course, lead generation. How can you efficiently detect companies that are more likely to buy your products or use your service, etc. And the main reason is when you look at the the usual approach that companies, B2B companies, use for tackling this challenge, well, they tend to rely on what I call offline data. So what I mean by offline data, well, it's simply data that are officially published by companies everywhere, right? So official firmographic data. So these data are usually very well structured. So think about the official activity code of a company or financial results, etc. These data are also very often static data. So when you think about financial data, well, if you're lucky, you will get updates about some of the prospects every month, or usually it's every year. Also, it offers a very low granularity. So in terms of official activity of a company, so let's say that you want to detect all companies that are offering big data analytics services in Sweden, right? Well, it will be very difficult to do this with this official data because there is no such specific category of big data analytics when it comes to these official activity codes that are called NACE codes in Europe. And finally, well, because these are static and structured data, in terms of machine learning or AI, people tend to use very traditional prediction methods, if they use prediction method at all for this. So of course, because of all this, well, we would need somehow to leverage all this contextual and online information that are actually available online about companies. So we need to have more dynamic and accurate information about companies in order to make better decisions. So the question here is, how can we actually leverage all these contextual and online information so that we can significantly improve performance of our systems? All right, so there are three key aspects I believe we should focus on when it comes to leveraging all this online information. So the first one is, you probably know this, but most of the information that are available online are completely unstructured, okay? So you can think about audio, video, but also images, and of course, textual documents. So roughly 80% of the data that we produce every day are completely unstructured. And the second point is, if you want to have a system that can efficiently process these very different types of data, well, you will need to let's say, to master or to use very different types of AI systems, or not AI systems, it's AI paradigms in this case. So, for example, you might want to look at deep learning so that you can better analyze images, or you might want to look at named entity recognition from natural language processing in order to detect entity names or to understand what people are saying about the company, right? So very different types of methods. And finally, you also need to focus on automation and scalability. So scalability, of course, in terms of infrastructure, so in order to store and to process the data, but also scalability in terms of geographies and languages. Because you want your system, your machine learning pipeline, let's say, to scale from one country to another very easily. Because when it comes to B2B lead generation, very often, well, there is no real boundaries. You want your system to work worldwide. All right. So what I would like to, let's say, to present here is what I believe is a very efficient machine learning pipeline to tackle this problem. And we will come back to this later on. And to make things a bit more concrete, I will also illustrate this with a practical use case, which is the Messe Frankfurt use case. So Messe Frankfurt is the world's largest trade fair, congress, and event organizer in the world. So they organize dozens of fairs everywhere, and each of these fairs are very different. So you can have one fair about the meat cutting industry, another one about the technical textile, and another one about pro light and sound. So about companies that are in the business of light and sound for concerts, for example. And of course, their challenge is that they want to detect leads for each of these specific fairs, so companies that would be interested to participate to their fair. And these leads, these companies, can come from anywhere in the world, so Asia, Africa, South America, Europe, etc. All right, and here I will focus on one specific fair. So this is called the Textile Fair that will take place in a few months in Frankfurt, and that fair focuses on technical textile. For example, from technical textiles that are used in the military industry or in the agro-tech, food tech, not food tech, sorry, the sports tech, etc. All right, so coming back to the original pipeline. So the first thing that you might want to do is, of course, is detecting pieces of information that are associated to companies you might be interested in, right? So how can you actually get all this online information? So this is the enrichment step. So in this enrichment step, so first, maybe we want to focus on different types of online information that might be of interest. So here, this is just a list of some online information that could be interesting, but there could be different types based on your business, of course. So one of them is, of course, the content of the website of a company, because a lot of things are being said there. Another one is the type of products that they are saying, or the types of publications, so what they are publishing actually. So, for example, whether they are introducing a new market and these kind of things. Of course, images that are associated to this company, or job posts. Okay, these are just a few examples. And let's say a very generic way to gather all of this information associated to certain companies, well, there are two ways to gather this. So the first one is to find the website of a company. The thing is that company websites are not always easy to find. I mean, you can look for it manually, right? But in this machine learning pipeline, you might want to somehow to automate this. So what we actually did, and what you can also do, is to try maybe to leverage search engine results. So you'd use a company name, and then plug it into a search engine, and then you can simply using, so here we used a gradient boosting algorithms, so machine learning algorithms, to analyze the different search engine results, and by looking at some features present on the website or not, we can train an algorithm to detect whether this website belongs to this company or not. Okay, this is one way to gather efficiently online information, because once you have the website, well, you can derive lots of information from it. Another interesting way is to detect all pieces of information online that are just mentioning this company. Okay, and for this, well, what you could do is that you could subscribe for free to all RSS feeds from all newspapers in the world, or all websites. Right, and this is actually the solution that we chose. So we are following more than 1 million news articles every day, and then we are relying on natural language processing, and more specifically name entity recognition, to detect whether a company is appearing within a certain article or within a certain piece of text, and then to disambiguate this information. So connecting this company name to the actual company name that you have in your database. Well, for this we use Elasticsearch. Of course, you can add as well offline data, so it's not completely useless, because in official data, well, for example, the company name, which is unstructured, which is completely unstructured, is actually useful as well. And you can also, if you want, take financial information or industry codes and these kind of things, because there is still a little bit of predictive power in this. And for our specific use case, we were able to, let's say, to enrich more than 11 million companies from more than 39 countries for the fair that I just mentioned. So the second step is the learning step, of course. So the first element, the first thing is how can we automatically extract useful information from these very different pieces of information. Or another way to say this is how to translate, how to go from this very unstructured data to, let's say, a very structured and numerical features that you can later on use and combine in your lead scoring model. So here we'll just focus on 3 different types of data and explain a bit how you could let's say, do this translation. So when it comes, for example, to products, so what are actually the type of products that matter to detect whether a lead is good or not? Well, for this, what you can do, remember that now we have access to the website of the company. You can use, you can use a text mining, for example, pattern matching to detect the product page on the website of a company. Okay, and once you have this product page, so the description, what you can do using training data, so you have a set of very good, let's say, clients or your best clients, and a set of either very bad clients or companies that are not interesting at all for you, right? So using this positive and negative set, well, you can look at the description of their product page, and you can learn, for example, using a naive bayes classifier, which keywords actually matters and which one do not. So in the case of the textile fair that I mentioned before, for example, elastic band, seat backing, and aristotapes would be extremely important. And in practice, there are, of course, thousands and thousands of keywords that are being weighted and that are being sorted in this case. A very different type of online elements you can look at is, of course, images. So you can look, for example, on the website, what are the different images that are being used. And again, using the same logic, what you can do is that you can, for example, use convolutional neural networks, deep learning, to translate images to a set of keywords or a set of labels, right? Describing what is on the picture. So the different topics, the different labels, the different elements, etc. So in our case, for example, for a textile fair, well, the algorithm by itself understood that if you have like images describing military equipments or specific fibers, or in the bottom here, specific machinery that can produce textile, well, if this is appearing on the website of a company, this is extremely important. So the probability will go higher. Of course. And as I said, you use a naive bayes classifier somehow on the labels that you have learned. And finally, maybe the most unusual data that you could use is network data. So how does this work? So the idea is that what you can do is that we want to reproduce somehow a network of companies, right? So you have companies, and we want to link them based on whether they know each other or they are interacting with each other. So it's information that are obviously very difficult to find, right? So the proxy that we use for this are actually hyperlinks. So two companies are linked together if one is referencing the other. And because we have millions of websites, well, we can reconstruct somehow a huge network of companies, okay? Once we have this huge network, the next step is, okay, but how can we actually use this or translate this into a numerical feature that we can easily use in a machine learning model? Well, what is interesting here is that a few years ago, there were new frameworks that were introduced to, let's say, to facilitate this translation between the network and numerical features that actually represent the topology of the network. And in our case, we used Node2Vec, the Node2Vec library, so Node2Vec framework, which is a Python library that is freely and openly available. Okay. And we can, of course, do the same, so this translation for the offline information. So if you think about company name, which is completely unstructured, right, it's textual data, what you can do is simply tokenize the text, and then using, again, a naive bayes classifier based on your positive and negative set to understand which keywords actually matters, okay? So in our case, if the company is mentioning filtration, textile, or technique in its name, well, this might be important as well. And here, of course, it's fully automated in this case. So once you have all your features that are being, let's say, that are somehow structured and numerical, well, then you can use the algorithm of your choice, machine learning algorithm, to combine all them. So practically what we use is a gradient boosting, because it's quite efficient at, let's say, analyzing and combining numerical features of very different types. Okay, and now you have your model that has been trained. So now the final part is the prediction phase. So there it's quite straightforward. So you take all the companies that you believe could be interesting, so maybe some are, maybe some are not, and then you will enrich them, and then you will feed that to the model that you just learned. And what you will end up with, well, is simply a lead score for each of these companies. All right? So these are an example of results, for example, that we got for the textile. And what you can see here is that the algorithm can efficiently distinguish good leads from bad leads. And depending on your use case, you might want to focus really only on the top 50 ones or the top 10,000 ones. And here, a very specific case. So I took one of the company that was actually on the top of our list, so you can see a lead score of 98%. But what is interesting here is that if you look at the official description of the company, so what they are officially stating they are doing, right? So apparently this company, if you look online, they are doing, so they are primarily engaged in manufacturing women's full-length and knee-length hosiery and pantyhose. So this is obviously not interesting at all for a tech textile, fair. So these are not technical textile, right? So you would discard it. But our algorithm still is saying that this is extremely interesting. So what we did is to look at, okay, but what kind of features indicated that it was quite interesting. And we saw that in terms of offline features, it was really not good at all, but online features were pretty good. And when you look at the actual website of that company, well, very quickly, you will understand that this is a very good one. You can see, of course, in the name there is fabrics. You can see there is a lot of keywords about innovation, textiles. In the pictures, you see parachutes. You see also sports, automotive, and these kind of things, right? So all elements that the algorithm was able to pick up. And finally, in terms of performance, what we did is to compare standard approaches that our customers were using. And on average, the performance was 13%. Okay, which is quite low. While when you leverage on top of the online information, on top of the offline information, the online information, well, there the performance are much higher. And these are not theoretical performances, right? So this is based on more than 10 different use cases for which we received feedback. And this is a huge improvement in terms of performance, right? So game-changing results. All right, so this was just, let's say, one example on how we can actually translate this, let's say, this evolution and use this contextual information. But this can be also used in many different other contexts. So thank you very much.